Welcome to the engineering lecture series. The title of our public lecture today is Solar Photovoltaic Technology as a Veritable Solution to Energy Crisis. In this part two, we'll be looking at building up scales for solar energy acquisition. Your anchor person remains Professor Michael C. Ndinechi. This lecture is a public lecture, named public lecture because you don't have to have prior knowledge in this area. The building up skills will enable you understand and engage effectively with any vendor you want to get solar energy system from. It enables you to understand all the aspects, even by visual inspection, know what you really want, whether it is what the vendor is providing for you. So the lecture is very important for people who are planning to acquire solar energy installation in their buildings, in their offices, and also for people who are already making use of solar energy system in one way or the other. This lecture will help them to understand better. So before we go on, please subscribe and follow me in my public lecture series by subscribing to my YouTube channel at https://youtube.com/@ndinechimicroc. Please like, share, and drop your comments in the comment section or reach out to me using my email addresses. It will also be very good if you listen to part one of this lecture. You can do that using the link stated below, or just go to my channel and check the playlist for public lectures. So we begin this lecture by saying that solar energy systems are becoming more popular around the world due to growing climate change concerns and because the technology is maturing very quickly. In part one of this lecture, I've dealt with benefits of using solar energy and the theory behind solar energy and photovoltaic PV technologies. So in this part two, you will be able to select the type of solar panel that will satisfy your pocket and need. If you follow us religiously in this part two, you will know how much you have to invest in solar system acquisition and know the specific needs you want to satisfy. Because it is cost intensive, you need to know exactly what you need and not what you want, so that it will not be heavy on your pocket. So this part two of the lecture on PV technologies will enable you to do that. Also, you will understand the basic components of a typical solar system. You can also figure out the size of system you need, not just because the vendor wants to sell, he proposes anything to you. You need to know exactly what you need to have. Also, you should be well on your way to designing your own moderate sized solar electric system, because if you know what you want, know how much your pocket can afford, then you'll be able to design what you want. When you do that, you can now go about the installation and or maintenance of your own solar power system with a feeling of confidence and self-reliance. Now, the starting point in acquiring solar energy system is to select your panels. So you must have to know the different types of panels that are available for you to select from. So when considering installing solar panels, you need to be guided and be conversant with the various types of solar panels that are available in the market and the advantage of each one over the other. There are 5 types of solar panels in existence. The first one is called the monocrystalline solar panel. Now, these monocrystalline solar panels are known for their high efficiency and sleek black appearance. So next time you see solar panels on rooftop of any building, check if they are of sleek black appearance. You will know automatically that they belong to the monocrystalline solar panels. Now, these monocrystalline solar panels are made from single crystal structure of pure silicon. They are highly efficient in converting sunlight into electricity and perform well in low light conditions. Monocrystalline panels are a popular choice among home users due to their high power output and long lifespan. But of course, they are more expensive than other ones we'll be mentioning. Part of the reason is that in part one of our lectures, we said that pure silicon is very expensive to process. So, and this monocrystalline is made from pure silicon. So that forms part of why they are very, very expensive. So the second one is polycrystalline solar panels. These polycrystalline solar panels are made from multiple silicon or multiple, at times called multi-crystalline panels. So they are made from multiple silicon crystals, and this give them a characteristic blue color. So, like we said before, if you look at rooftop and you see, or you go to your vendor's shop and you see those ones that are bluish in color, you know that they belong to this class of polycrystalline solar panels. They are slightly less efficient than the monocrystalline and therefore are more cost effective. They are a popular choice for residential and commercial installations because they offer good balance of performance and affordability. If we look at the first one, monocrystalline, we say it's high efficiency and very costly. Now, this is not made up of pure silicon. So the cost reduces and the performance is enough to take care of residential and some commercial installations. So we say that it gives good balance of performance and affordability. The third one is the thin film solar panels. also known as the amorphous panels. So the thin film solar panels are made from a thin semiconductor material such as amorphous silicon or cadmium telluride. In one of my lectures, I have talked on semiconductors. So if you want to know more about semiconductors, you can, refer to that my lecture, which I also mentioned in part one of this series. So these are not really crystals, but just a thin layer of silicon deposited on a base material such as metal or glass to create the solar panel. You can see the panel is not full of silicon, but a thin layer of silicon deposited on the material. Now, these panels are lightweight, flexible, you can fold them, flexible, and have a lower cost and efficiency compared to the monocrystalline and the polycrystalline panels. So you see that it is not as expensive as the other ones because of the way it is made, limited silicon. So they require more installation space to get equivalent capacity compared to crystalline panels. When we say crystalline panels, we are referring to either monocrystalline or polycrystalline. So this thin film is less expensive, less efficient, and requires more space to be able to get the equivalent of those other crystalline panels. Now, the fourth one is the bifacial solar panels. So we also have bifacial solar panels which have the unique ability to capture sunlight from both the front and the back sides of the panel. They are constructed with a transparent backsheet, allowing light to pass through and be reflected back onto the solar cells. In part one of this lecture, when we talked about the constituent part of the cell itself, we say that it is made of a plate and another backsheet on top and below a semiconductor wafer. Now, we are saying that this process, if it is constructed using a transparent backsheet, then it can allow reflected ray from the ground or from another surface to be captured by the back sheet, so that when the panel is facing up, under it we also be getting some reflections from the sun. So we say this technology increases the panel's overall energy production because now it is two-phase production of electricity. So increases the panel's overall energy production and performance, especially in areas with high surface reflectivity. Bifacial panels are gaining popularity for their increased energy yield and design versatility. The fifth one is called the building integrated photovoltaics, BIPV. So these BIPV solar panels are designed to seamlessly integrate with building materials such as solar roof, tiles, solar windows, solar packets. So instead of mounting solar panels on top of your roof, these solar panels will now be made to be used as the roof itself. So if you put it, it means that part of your building is the panel itself. It can also be used to be construct the windows and some other, designs of the building. So with that, you don't have to go separately to install the solar panels. Part of the building materials you are using to build your house automatically becomes the solar panels themselves. So these panels serve a dual purpose by generating electricity while also acting as architectural elements. BIPV panels offer a visually appealing solution for incorporating solar energy into building designs, making them suitable for both residential and commercial projects. The typical prices of different types of solar panel in the market range from 12,000 Nigerian naira to 350,000 Nigerian naira in the market, depending on the output wattage as tabulated below. Now, the prices are not the same. For instance, we've mentioned that of monocrystalline panels are more expensive than the polycrystalline, than the thin film or the amorphous panels. So, depending on the one you want to buy, we have here stated their power output in watts and price ranging associated with them. For instance, if you are looking for a solar panel of about 20 watts, you see that you'll be able to pay between 12,000 Nigerian naira to 26,000 Nigerian naira. Just like that down, you see there are different, makes. We just, selected some, wattage. There are higher wattage than 550 watts, so the prices increase. So depending on how much money you have to spend and the quantity of wattage your load requirement is, that will give you a faint idea of how much you should be setting aside to get what you want. So it's very important. For instance, if you are looking at 1,000 watt and you want to acquire 250 watt panel, you see that if you get 4 pieces of the lowest quality at 100,000 naira per one, you can see that with 400,000 naira, you will acquire the panels. If you are looking for the higher quality, you can now scale up to 180,000. So with this, you'll be able to gauge your pocket and know how much you are ready to sunk into the acquisition. Now, after the solar panel, the next thing you must look out is for the charge controller. So the charge controller is an electronic device used in off-grid and hybrid off-grid applications to regulate current and voltage input from the PV arrays to their batteries and the electrical loads. Now, what do we mean by this? The solar panels stored on top of your roof is connected through this charge controller either to the batteries to store so that when there is no sunshine, the battery will feed you back, or if you have electrical loads that are connected direct to the panels, that is, if you have electrical um, equipment or devices that make use of DC supply, you can connect them direct to the solar panels. So if you don't have and you must convert to AC, then you need a charge controller to do that. This charge controller maintains highest state of charge without overcharging the batteries so as to avoid gassing and battery damage. Now, in our next lecture, when we look at the types of batteries, you see that some batteries can emit gases. If the charge controller is not working according to design, you see that the batteries will be emitting more gases as required, and this will definitely damage the battery. So a good solar charge controller can extend your battery life, whereas a poor quality one can cause battery failure. A wrong charge controller can lead to the entire off-grid system shutdown. Here, when we talk of off-grid, we are talking of standalone. If you have solar and you're not making use of, public power supply, we call it off-grid or standalone system. If your charge controller is not working according to design, then your system will be in trouble. A good charge controller also delivers proper current and voltage that meets the rated capacity of electrical loads, thereby prolonging the battery life. Without a charge controller or using the wrong charge controller, we deliver too much power, which will destroy whatever you have, including the battery you are using to make the storage. Now, how does a typical solar charge controller work? We don't want to bother you much here because for you to understand this very well, you have to have a prior knowledge of some electrical engineering. But let's quickly look at it. Now, solar charge controllers typically deploy either the pulse width modulation technique, which is also in one of the lectures I've given in my YouTube channel, or the maximum power point tracking known as the MPPT, the technology to regulate and deliver the right amount of current and voltage from the PV arrays. We try to mix up PV, photovoltaic arrays, or solar panel arrays. So, and this to run electrical load safely and safely, charge batteries during the day. Then during the evening, when there is no sunshine, the controller allows the battery bank to run the electrical loads. Solar controllers have electronic protections to protect against nighttime reverse current, short circuiting, high voltage, high temperatures, and battery reverse polarity. I want you to just, don't mind all the terms, but take high voltage, high temperature, short circuits. These three are simple to understand. So when they occur and you are using the right charge controller, the charge controller takes care of them. Additionally, some controllers have low voltage disconnect capabilities and are equipped with LED warning lights. When we say LED lights, emitting diodes, warning lights, or beeping system to alert you about installation errors and faults within the system. For instance, some of them use the 04 beeping signal to indicate when the battery is discharging and is going very low. They use that beeping signal so that when you hear it, you know automatically that your battery is getting down. If you have urgent thing to do, then you have to find an alternative supply before it goes off on its own. The next thing after the charge controllers are the inverters. And the inverters come in different shades. So some inverters convert the low voltage, solar inverters convert the low voltage direct current to the 230 volts alternating current that runs most appliances. If you check most of the appliances you have in your homes, you will see they will be rated 220, 250 volts. So we take the middle of that to be 230 volts. So the work of the solar inverters is to convert the low voltage direct current that comes from the you know panels stored in the battery back to the system or the way your appliances can make use of them. They are the mainstay of any solar energy system. If you don't have a solar inverter, you don't have any solar energy system. The job of the solar inverter is to accept DC power input from the solar panels and turn it into AC power that is needed to power your appliances and also to connect any standalone system to the grid. In most homes, you see that you have your public power supply, you have your solar inverter. When the public power supply is on, your solar system will be resting, and when it goes off, your solar system takes charge. So it is this power inverter that coordinates this activity between the public power supply and the solar system you have in your home. So that they also act as the main connection between the solar panels and the electrical distribution panel in your homes. Solar inverters deliver many benefits beyond the action of just converting this DC to AC. For instance, so solar inverters continuously monitor the voltage of the solar array to determine the highest power over which the models can operate. Modern smart inverters are capable of two-way communication, making them capable of supporting the grid. With software, smart inverters can carry out several grid supporting operations. Solar inverters are designed to shut off if an electric arc occurs, which is a major risk factor due to material deterioration over time. Now, it is important here for us to know what we mean by electrical arc. In most cases, when people talk of electrical arc, uh, some people think that it is maybe voltage surge or this. Not necessarily. When you have lightning and thunderstorm, it affects your solar inverters seriously. Immediately there is a spike, which is called the electric arc. So, as a starting point, when you want to acquire solar PV system, the first thing is to get a specialist to check the level of heating in your home. If your home is not well heated, then you'll be frequently running into problem of your inverter having issues anytime it rains or anytime there is serious thunderstorm. So if you are planning in near future to acquire solar energy system, please, the first thing you will do is to get an expert to check the heating of where you are going to install that solar system. Without that, your power inverter will always be having issues. There are three popular types of solar inverters available to users. They are the square wave inverters, modified sine wave, and the pure sine wave inverters. The square wave inverter is not very suitable for operation of many equipment, and they are inefficient. If a vendor wants to supply you inverter, please find out, is it a square wave inverter, a modified sine wave, or a pure sine wave inverter? Like we have seen, the square wave inverter is not very stable for many operations and are inefficient. They have shorter battery life due to high energy loss. They portend higher risk of damage and contribute to the malfunctioning of sensitive electronic devices. If you're using square wave inverter and you are using sensitive electronic devices, there is likelihood that those devices will be having issues from time to time. They are inexpensive due to lesser compatibility, lesser efficiency, and limited use. Of course, it is understandable that when many electronic devices do not make use of them, they don't support them, so there will be fewer demand for it. And when you have fewer demand, then it becomes a bit inexpensive to be able to stay in the market. They are not very good for home appliances, but very preferable where simple electrical devices such as power tools and heating elements, incandescent light bulbs are the primary targets. What you are saying here is that if, for instance, you just want to be, using it to heat and light your bulbs and probably use, power tools, yes, you can use square wave inverters. They can do that, but not when you are using things like laptops and, if you use square wave inverters, you will be sure that your laptop or your medical equipment will be having issues every now and then. The second one is the modified sine wave. The modified sine wave inverters are the most popular and most economical solar inverter. It produces an AC waveform somewhere between the square wave type and the pure sine wave type, which is good enough for many home appliances. What you are saying here is that this modified sine wave, because it is not pure sine wave, it is not as expensive as the pure sine wave, but its output is good enough for use of many electronic appliances found in homes. So it becomes, a choice because don't want to spend so much. But if you have so much to spend, you can go for the pure sine wave inverters. Their pricing are also lies between the square wave and the pure sine wave prices. However, they are not suitable for appliances that use timers and appliances that use motor speed controls. If you use modified sine wave on that, you see you'll be having some issues with them. So remember what we have said, for the square wave is used for where you have heating incandescent bulbs. When we say incandescent bulbs, there are those lighting bulbs that when you look at them, you see a thin filament inside them. Those type of bulbs use 90% of the energy supplied to them for heating and only about 10% for lighting. So it is more of a heating device instead of a lighting device. So what we are saying here is that is for square wave, but for other items, please use modified sine wave because it is economical. Not that it is the best. It is the most economical that can serve most of the home appliances you need. Now, the pure sine wave inverters has output that is closest to true sine wave. When we say sine wave, we are talking of pure sinusoid. Because of its high quality output, it is compatible with a wide range of devices, especially sensitive appliances such as laptops, smartphones, refrigerators, microwave ovens, and medical equipment. What we are saying here is clear. If you are purchasing an inverter, remember the square wave inverter will be very cheap for you. But it is good to know what are you going to use in your home. Are you going to use laptops, smartphones, refrigerators, or other medical equipment? If you are going to use them, please do not go for the square wave inverter because it is cheap for you. It will cause you more harm than good. We are saying that you should get the modified sine wave type. If it is possible for you, you get the pure sine wave inverters because of what you have said. So in summary, they generate smooth and continuous wave identical to the grid supply. The type of wave they generate is identical to the one from the public power supply. like I've said, when we talk of grid, we are talking of public power supply. They are stable for all types of electronic appliances, and they are more efficient due to less energy loss and heat, which gives it longer battery life. So if you use the pure sine wave, then you will be sure that your battery will be staying longer. If you use this type of inverters, you can see that it will give you more hours with lesser battery when the sun has gone off. Else, if you use the other ones, maybe 2 hours after the sun sets, your battery start beeping and will go off. So it is a trade-off depending on the amount of money you have, you want to put in, the equipment you want to use. That will help you to know what are the equipment, that is the panel you will purchase, the charge controller you will use, and the power inverter you will use. So in our next lecture, we will look at the types of batteries and the reasons that will make you choose any particular one. We will also look at the wire sizes that are suitable for a particular installation. For instance, if you are living in a three-story building and the solar panels are up there in the third floor and you are living on the ground floor, then the type of wires you will use will not be the same for somebody who is living in the third floor and the panels are just on the roof. So in our next lecture, if you join us, you will be able to see what sizes of cable or wire you will use and the distance they will take you to give you a good output. Also, in that next lecture, we will study a table that relates the size of this wire and the length for connecting your inverter, the length for connecting your charge controller, and the length for connecting your batteries. We will take a typical case study and use it to, see how this works together. Remember, the essence of what we are doing is that if you are going to acquire a solar energy system, you should be able to know so much so that you'll be able to engage your vendor very accurately and understand whatever he is doing with the final thing in mind to be able to do minor servicing if any fault occurs. Finally, in our next lecture, we will look at independent and semi-independent systems. By independent systems, we mean systems that are standalone, and semi-independent one are the hybrid ones with the grid. Then after that next lecture, like we said at the beginning, that having a solar panel on top of your roof can help in decarbonization of the environment. And you can earn a lot of money having solar panel on top of your roof. Subscribe to my lectures so that when we will talk on that all important aspect of earning money from having solar panels or making use of this solar photovoltaic systems, you will get notifications when we will do that. Thank you for listening. Please share with others, because this is not a pure academic work, but a public lecture to sensitize people on how they can acquire solar system and how they can make money out of it. Thank you for listening.